Auzu billahi minesh-shaytanir-rajim. Bismillahir-rahmanir-rahim. Allahumma salli ala sayyidina wa maulana Muhammadin wa ala ali sayyidina wa maulana Muhammadin wa barik wa sallim. Assalamu alaikum dear students. Today we will solve some more questions regarding space physics. Let's start. This is question number 6. The statement of the question is, the Pluto is a dwarf planet. Figure 6.1 shows the direction of motion of Pluto as it follows its elliptical orbit around the Sun. The question is part A. Point X is the point in the orbit closest to the Sun and point Y is the point farthest away. The orbital speed of the Pluto varies as it orbits the Sun. The question is, part 1, describe how the speed of the Pluto varies as it moves from X to Y, then back to X. Dear students, keep in mind, variation in the speed of any planet around the Sun, if it has an elliptical orbit, is due to gravitational pull of the Sun. As the planet moves closest to the Sun, due to more gravitational pull, its speed increases. But when the planets move away from the Sun, its gravitational pull decreases. So the speed of the planet also decreases. So we will write our answer like this. Our answer is, speed decreases as it moves from X to Y. Speed increases as it moves back from Y to X. Now part 2, explain in terms of energy transfers why the speed of the Pluto varies in this way. Dear students, as the planet moves away from the Sun, its gravitational potential energy increases, and when a planet moves closer to the Sun, its gravitational potential energy decreases. And during the orbital motion, the kinetic energy converts into a potential energy, and potential energy convert into a CAIE. As the planet move from closest to the farthest position, its kinetic energy convert into a potential energy. And when the planet move from farthest position to the closest to the Sun, its gravitational potential energy convert into kinetic energy or CAIE. Because the speed of the planet increases when it moves from farthest to the closest position, and its speed decreases when it moves from closest to farthest to the Sun. Our answer is, the gravitational potential energy GPE transfers to CAIE, kinetic energy. CAIE transfer to the gravitational potential energy. As its speed decreases from X to Y, gravitational potential energy is maximum at Y and it is least minimum at X. And the total energy always remain constant or conserved. So sum of potential energy plus CAIE will remain constant. Now part B. The average temperature on the surface of the Pluto is 43 Kelvin. Convert this temperature to a value in degrees Celsius. Dear students, we have equations which convert Kelvin to degrees Celsius. That is, degrees Celsius is equal to K minus 273. So our answer is minus 230 degrees Celsius. Now part 2. Pluto has white surface as shown in figure 6.2. As Pluto rotates its white surface, the white surface alternately faces towards and away from the sun. The question is explain how this affects the temperature of the Pluto as it rotates on its own axis. The white surface is a poor absorber, poor emitter, but good reflector. And black surface is a good absorber, good emitter, and bad reflector. Our answer is white surface is a poor absorber, poor emitter, poor radiator of infrared rays, but good reflector. This affects the temperature of the surface of the Pluto. Now question number 7. State the equation that defines the average orbital speed v of a planet. State the meaning of any symbol you used. Dear students, formula for the orbital speed is v is equal to 2 pi r over t, where r is the radius, t is the time period, and v is the speed. Its part B is suggest why country that are a significant distance from the equator experience significant temperature variation throughout the year. As we know that the rays coming from the sun fall at different angle on different part of the planets. That's why there is a variation in the temperature. So our answer is rays from the sun strikes the country at different angles throughout the years, even for different number of hours per day through the years. That's why there is a variation in the temperature on different part of the planet. Now the part C, fill in the gaps in the paragraph about the star which more massive than the sun. The stage that follows the stable state in the life cycle of a star is the red supergiant stage. It then explodes as supernova to form a nebula. This leaves behind a neutron star or a black hole. Question 7, part D. A galaxy is moving away from the Earth with a speed of 33,000 km per second. The value of the Hubble constant is 2.2 10⁻⁻18 per second. Calculate the distance from the galaxy to the Earth. Give your answer in light year. Dear students, as we know that the Hubble constant formula is H naught is equal to V velocity and the distance. From this D is equal to V over Hubble constant. When we put the value in this formula, we have 33,000 kilometer. So we have to convert this kilometer into meter. For this we have to multiply by 1000 divided by 2.2 10⁻⁻18. We will get the answer 1.5 10⁻25 meter. But in the question we have to find the distance in light year. As we know that 1 light year is equal to 9.5 10⁻15 meter. For this we divide 1.5 10⁻25 by 9.5. We divide by 9.5 into 10⁻15. Our final answer is 1.6 10 power 9 light year. Now question number 8. Figure 8.1 shows the Sun as a central dot and the planets Saturn, Jupiter and Earth labeled S0, J0 and E0. The planets orbits the Sun anticlockwise. From the Earth's orbit, the planet appeared aligned. Assume that the Saturn take 30 years to orbit the Sun and the Jupiter take 12 years to orbit the Sun. The part A is on the figure 8.1, mark the position of the Saturn and Jupiter 5 years after the original position shown. 5 years after the original position shown. Label these positions S1 and J1. Show your working. Dear students, in this statement, the time period for the Saturn to complete one cycle is 30 years and for Jupiter it is 12 years. So, as we know that in a complete cycle there are 360 degrees. Now we will find the position of the Saturn and Jupiter by calculating the angle after 5 years. 30 years of a Saturn is equal to 360 degree. Then we will find the angle for 5 years. For 5 years we have 360 degree over 30 into 5. This is equal to 60 degree. So we will mark the position of a Saturn from this original position to the 60 degree in anti-clockwise direction. As we know that from the center this angle is 90 degree and its half is 45 degree. Its half is 45 degree. Its half is 45 degree. So the 60 degree is almost like this in this area. So this may be the position of the Saturn S1. Now the Jupiter, its time period is 12 years. In 12 years it complete one oscillation. It means 12 year is equal to 360 degree. In 5 year it would be 360 degree over 12 into 5, which is equal to 150 degree. So now we will mark the position of the Jupiter at 150 degree from its original position. As we know that from this position of the Jupiter, this would be the 180. The angle is 180 here, and but we have to mark at 150 degree. So approximately its position it would be at this. So this is the possible position for a Jupiter. This angle is 150 degree. Part B1 is on figure 8.1. Mark the position of the Saturn Jupiter 20 years after the original position shown in figure 8.1. Label these positions S2 and J2. Dear students, by using same formula, we will calculate the angle. We will calculate the angle for 20 years now. For a certain 30 years is equal to 360 degree. Now the 20 years is equal to 360 over 30 into 20. This 0 is cancelled by this. 3 1s are 3, 3 12s are 36. So the answer is 240 degree. Now for Jupiter, as its time period is 12 year, 12 year is equal to 360 degree. Now 20 years is equal to 360 degree over 12 into 20. Its 240 degree is approximately at this position. This is S2. Similarly, the angle for Jupiter is also 240 degree. So the position of the Jupiter will be at this. That is J2. Its second part is state what is observed from the Earth's orbit after 20 years. Jupiter and Saturn are aligned in front of each other. Part C is C1. Choose two words from the list to describe each planet. The words are gaseous, large, rocky, small. Jupiter is gaseous and large, and Earth is rocky and small. Part 2. The average density of the Jupiter. The average density of the Jupiter is much less than the Earth. The gravitational field strength at the surface of the Jupiter is greater than that at the surface of the Earth. Explain how these differences in density and in gravitational field strength are consistent with your answer C1. First of all, the density. Dear students, as we know that Jupiter has a large volume than Earth and is gaseous, so its density is low. The gravitational field strength, GFS, is large. Gravitational field strength is large than Earth because of its large size, mass and large volume than the Earth. Now the part D, the average density of the Jupiter is 1300 kg per meter cube and its volume is 1.4 10 raised to power 15 kilometer cube. Calculate the mass of the Jupiter. For this we will use the formula density is equal to mass over volume, rho is equal to m over v. From this, m mass is equal to density into volume. So by putting the value in this formula, but the volume is given kilometer cube, so we have to convert the kilometer cube into a meter cube. For this we have to multiply it by 1000 into 1000 into 1000, and our final answer is 1.8 10 raised to power 27 kg. Now question number 9, part A. Show that 1 light year is equal to 9.5 10 raised to power 15 meter. The speed of light is 3.0 10 raised to power 8 meter per second. So by using this formula, the distance is equal to speed into time, we can convert this light year distance into meter. As we know that in 1 year there are 365 days, and in 1 day there are 24 hours, and in 1 hour there are 3600 seconds. So we will multiply all these values to convert the 1 light year distance into meter. So our answer is as shown. Now the part B, state one measurements that is taken when determining the speed v at which the galaxy is moving away from the Earth. Its answer is change in wavelength or the redshift. Its part 2 is write down an equations relating v and the distance d for a distance d of a far galaxy. Students, its formula equation is h naught Hubble constant is equal to v over d. Now the third part, state how the distance d of a far galaxy can be determined other than using the equation 2. Dear students, now for the part third is dear students, now the answer is we can calculate its distance d as the galaxy is moving far away instead of using a Hubble constant equation from the brightness of the supernova. Now question number 10. Figure 10.1 represents the sun and a part of a solar system. The question is, A part, complete the labels on figure 10.1 by writing on the dotted line. So in this figure 10.1, the solar system is shown. The missing names are Venus is our Earth, and around the orbit of the Earth, the moon of the Earth. Now part B, complete the sentences about the sun. The sentences are, the sun consists of mostly the element that is hydrogen and helium. The most of the sun energy is radiated in the infrared, visible light and ultraviolet rays region of the electromagnetic spectrum, and ultraviolet region of the electromagnetic spectrum. Now the part C, give the estimate for the diameter of the Milky Way galaxy. Dear students, diameter of Milky Way galaxy is approximately 100,000 light year. Dear students, now question number 11. There are 8 planets in our solar systems. Table 11.1 shows the name of some of the planets in order of the distance from the sun. Its part A is complete the table 11.1 by writing the name of the other planets in order of increasing distance from the sun. Dear students, I have already filled this table for you according to the distance from the sun. As we know that the first planet is Mercury, the second is Venus, number 3 Earth, number 4 Mars, number 5 Jupiter, number 6 Saturn, number 7 Uranus and number 8 Neptune. Now part B, the planets in table 11.1 orbits the sun. State the name of 2 other type of natural objects that orbits the sun. Dear students, There are many other objects orbiting the sun. Now we will write few names. Number 1, dwarf planets, which are known as minor planets, asteroids. In number 2, we may write comets, moons, natural satellites. Now part C, complete the sentence to describe Mercury and Jupiter. Use the word from the list. The words are large, rocky, gaseous, small, liquids. As we know that the planets which are closest to the suns are rocky and small, and which are further away from the sun are gaseous and large. So Mercury is rocky and small, Jupiter is gaseous and large. Now question number 12. The statement of the question is, figure 12.1 represents the earth in orbit around the sun. The diagram is shown, which is not to scale. The distance between the sun and the earth is shown in the diagram, which is 1.5 × 10⁻11 meter. The part A, first state the name of the force that keeps the earth in the orbit around the sun. The answer for A first part is the gravitational force of attraction. A part 2, state the time taken by the earth to complete one orbit of the sun. Include the unit. As we know that our earth complete one rotation about the sun in 1 year, which has 365.25 days. So our answer is 365 1/4 days. The third part, state the time taken by the earth to rotate once on its axis, include the unit. As we know that our earth complete its rotation about its axis in 1 day, and 1 day has 24 hours. So the earth complete its rotation on its axis in 24 hours. Part 4, the sun consists of mainly of two gases. State the name of the two gases. Students, we have already done this in previous question. The gases names are hydrogen and helium. Now part B1. The most of the radiation from the sun consists of a visible light and two other regions of the electromagnetic spectrum. State the name of one of the other two region. We have to write the name of the one region. So we may write infrared radiations, or you may write ultraviolet rays. B, second part, the speed of the visible light is 3.0 into 10⁸ meter per second. Calculate the time taken for a visible light to travel from the sun to the earth when the earth is in the position shown in diagram. Dear students, in the diagram, the distance between the earth and the sun is already given, that is 1.5 10⁻11 meter. So we use the formula speed is equal to distance over time, and from this time is equal to distance over speed. By putting the value in this formula, we get our answer, which is 500 seconds.